Hello, everyone, and thank you for joining the webinar. Today's presentation, Defend the Flock, Controlling Salmonella in Commercial Poultry Through Biosecurity, is part of the USDA's Defend the Flock campaign, promoting awareness about the importance of biosecurity and ways to prevent the spread of infectious poultry diseases. We are here today to support you and your flocks with expanded biosecurity resources. I'm Dr. Taylor Gaines with the USDA. Today, I'm joined by my USDA colleague, Dr. Catherine Burden, Laboratory Coordinator for the National Poultry Improvement Plan, and Dr. Charles Hofaker, President of the Southern Poultry Research Group and Professor Emeritus at the University of Georgia. A few housekeeping items before we get started. First, we want to let you know that real-time streaming captions are available for this program. To view, you can click on the CC in the bar at the bottom of the screen or type the caption URL that you see on this slide, bit.ly/oct5-webinar into your browser. The URL appears at the bottom of every slide, so you can link to captions at any time during the program. Note that the URL is case sensitive. To submit questions, click the Q&A button also located at the bottom of the screen. APHIS and our guests will answer all questions after the webinar has concluded. The Q&A will be posted, along with a recording of this webinar, on the APHIS website. Be sure to follow the Defend the Flock campaign on Facebook and Twitter to find out when the Q&A and recording are available. We'll share those online destinations at the end of the webinar. Now we'll take a few minutes to introduce ourselves. I'm Taylor Gaines, and I'm a veterinarian in the USDA Poultry Health Team. I graduated with a Doctor of Veterinary Medicine and a Master of Public Health from Virginia Maryland College of Veterinary Medicine. Dr. Burden, please tell us a little bit about yourself.
Thanks so much, Dr. Gaines. Hey everyone, my name is Dr. Katie Burden. I am the Laboratory Coordinator within the National Poultry Improvement Plan. I got my DVM from the University of Georgia and have a Bachelor's of Science in Poultry Science and Dairy Science from the University of Georgia.
Thank you, Dr. Burden. Dr. Hofaker, please tell us a little bit about yourself.
I'm Chuck Hofaker, veterinarian from Ohio State and Master of Avian Medicine from Georgia and PhD from Georgia. And I was the first veterinarian that Ross Breeders had in the United States. And I was on faculty at the vet school at the University of Georgia for 18 years.
Thank you, Dr. Hofaker. Now I will turn things over to you to begin our discussion about Salmonella and how it affects poultry.
First off, Salmonella is a gram-negative bacteria. So it's a bacteria that is in the same family as the bacteria that causes air sacculitis most frequently in broilers. And that's E. coli. So Salmonella is in that family, and there's actually two major groups. There's the typhoids that cause disease in chickens, and the paratyphoids. And the paratyphoids are the ones that we will spend most of today discussing. Those are the Salmonellas that can lead to foodborne illness in people. Next slide, please. This quote from Dr. McCape's from the proceedings of a Salmonella symposium is one of my favorite because it really sums up what we're trying to fight against as we try to control Salmonella. And it's an organism that has a really simple life. All it wants to do is find an intestinal tract of a host animal, and that can be multiple different species. It doesn't have to be a chicken. Multiply in that intestine and then get out of that host intestine and find another intestine to get into. That's all it wants to do. It doesn't want to do anything more complicated than that. Next slide, please. So Salmonella are not all the same. There's 2,500 different Salmonella serovars within those paratyphoids. And just like people, not all those Salmonella behave the same. Some are heat tolerant. Some live only in the intestines and won't get into the internal organs. Some can survive long periods of time for years in the dry environment. So we can't think of Salmonella as all being the same. Therefore, the strategy that we put in place to eliminate or reduce the level of Salmonella in our flocks may vary with the Salmonella cerevisiae that we have infecting those flocks. Next slide, please. We can't forget the typhoids, because the typhoids, Salmonella pylori, Salmonella gallinarum, nearly wiped out the broiler industry and broiler breeder industry in the United States in the 30s. And it's really the impetus for the creation of the NPIP, the National Poultry Improvement Plan, because these two types they specifically infect chickens. They won't make people sick, but they will kill hens. So adult chickens can be killed by Salmonella pylori or Salmonella gallinarum. And it will have a negative impact on, if it doesn't kill them, it can have a negative impact on their body weight, which can lead to decreased egg production and egg yolk peritonitis. So the typhoids are diseases that we've tried to eradicate from poultry in the United States. Next slide. An example, and one of the old names for Salmonella pylori is bacillary white diarrhea. So bacterial diarrhea in baby chicks. And you can see that in that picture on the left. That's Salmonella gallinarum. But it makes baby chicks sick if they get Salmonella pylori or gallinarum from the hen. Next slide. So let's talk more about the paratyphoids. Next slide. The sources of Salmonella for our hens or for broilers is a long list, because Salmonellas aren't specific host in a chicken. And we'll talk some about each one of these. Next slide. Keep in mind that Salmonella can be transmitted from one generation to the next generation. That's why NPIP began working with the elite pedigrees, and the GGPs and the grandparents of the primary breeders, so that we stop pylori and gallinarum from coming down through the chain. But we also want to look at the paratyphoids, the Salmonella Heidelbergs or Typhimuriums or Enteritidis, to try to keep them from transmitting from one generation to the next and getting all the way down to the consumer and causing foodborne illness. Next slide. So I'll give you an example of why I think Salmonella can be transmitted from one generation to the next. Dr. John Maurer and I did a study many years ago where we looked at 49 poultry farms, made 240 farm visits, collected almost 7,500 samples and 1,600 isolates of Salmonella. And we also had the primary breeder for that broiler company supply us with Salmonella isolates so we could see through the generations. And what we found was the next slide, please. That the major Salmonella was Salmonella Kentucky. And we fingerprinted it and we called it Salmonella Kentucky #1. We found other Salmonellas, but that Salmonella Kentucky #1, that fingerprint was exactly the same Salmonella that we found in the primary breeders. We found it in the pullets. We found it in the adult hens, in the broiler house, and we also found it in Sika in the processing plant. So the same genetic type Salmonella Kentucky was being transmitted all the way through multiple generations, all the way to the processing plant. That's why it's important for us to reduce or eliminate Salmonella at each of those steps through the broiler production chain. Next slide, please. So is Salmonella actually truly egg transmitted? Dr. Richard Gast at USDA and Russell Research here in Athens, Georgia, looked at the true transovarial transmission of SE. So he infected hens with SE, he sterilized the outside of the eggs, cracked them open, and he cultured just the internal organs of those eggs. And only 1 in 20,000 eggs had Salmonella on the inside. Well, we know the rate of transmission is higher than that. So my opinion, why so much Salmonella ends up going through the generations is that as an egg cools, the hen lays an egg, her body temperature is say 105 degrees. Well, the outside temperature is 46 degrees. The minute that egg comes out of that hen, it begins to cool. And it begins to cool and suck air in from around that nest, wherever that egg is being laid, or if it's on the floor, floor eggs. In the summertime, if we have eggs in a cooler and take them out, what happens when you have a glass of iced tea in the summertime and you walk outside? It sweats. Well, that sweating allows bacteria to get into that egg. So egg cooling, egg sweating, cleanliness of shell eggs is very important for us to reduce the transmission of Salmonella from one generation to the next. Next slide, please. To me, controlling Salmonella is a numbers game. We want to reduce the number of Salmonella that our flocks are exposed to. We can reduce the number by biosecurity, by reducing the Salmonella in inputs into that flock, or by the interventions that we put in place to help reduce the level of Salmonella that our hens are exposed to. Because a hen that's older can keep from becoming infected with Salmonella by as many as 100 to 1,000 Salmonella cells by some of by normal flora and by other immune responses, say from vaccination. So if we keep the numbers low, then the natural protective mechanism by the older bird can help reduce the chance of colonization. Next slide, please. So how can we control Salmonella in our poultry? Well, once Salmonella is established in a flock of birds, it's nearly impossible to eliminate that Salmonella. So our goal needs to be, don't let them be infected in the first place. Even antibiotics cannot be very successful in eliminating Salmonella positive flocks and making them become Salmonella negative. So once introduced, once a flock is Salmonella positive, it's difficult to eliminate, and we have to test the birds or their environment to determine if Salmonella is present. And one way to test a breeder hen environment or breeder hen flock is to culture the chick papers from the hatchery. Because if they've transmitted it to the next generation, it'll show up in that meconium, that first feces from baby chicks. Next slide. A flock of hens that is positive for Salmonella, really the only opportunity to eliminate it is to eliminate that flock of hens. That seems pretty harsh, but in my experience of dealing with Salmonella for almost 40 years is that once a breeder flock is positive, they are always going to be positive and they will intermittently shed. And it can take a long time to eliminate Salmonella by this stamping out method. But in reality, that's the only way to do it, to eliminate it, especially those that can cause human illness like Salmonella typhimurium. So biosecurity isn't going to completely eliminate the risk, but it'll reduce the numbers and help us control the risk. Next slide. So this student, who's now a veterinarian over in the UK, I asked him to stand in front of a mirror. because I want you to stand in front of a mirror. You, as a poultry manager, are the most critical factor. The decisions you make in managing your flocks are critical in your success to control Salmonella. Next slide. So how do we prevent Salmonella from getting into our flocks? Next slide. If that square box in the center is our chicken house, and we have a brand new chicken house, never put any chickens in there, never put any feed, never go into that house, don't let any insects get in there, we're not going to have Salmonella in that house. But the minute we bring in chickens or people or litter or feed or let rodents or wildlife get in there, then we have the opportunity for Salmonella to come in. So rather than trying to focus on all those things at once, let's break it down and look at those areas that may be the most critical for us. And for one complex, insects may be the big problem. For another complex, it might be vehicles or people. So it's not always the same in every location, nor is it the same for every poultry house. Next slide. Flies. Since you were a child, what do when a fly lands on your plate? You're out having a picnic. You shoo it away because your mother told you flies carry germs. Well, Salmonella is a germ, and flies can carry Salmonella for as far as 3 miles. So just the common housefly can be a source of Salmonella. Next slide. Darkling beetles. I don't think there's a chicken house in the United States, maybe very few in the world, that don't have darkling beetles. These guys live down in the litter. They burrow into the litter. And in the US, where we have dirt floor, they'll burrow into the dirt floor. And they go through 7 pupation stages. Those worm-looking things are the pupa. And the adults are the dark black beetle. And that's the gizzard of a baby turkey. If I were to put a pile of feed in front of a bunch of chickens or turkeys and beetles scurrying around, which do you think they're going to eat? They're probably going to eat the beetles because they're naturally going to look for things scurrying around. The University of Arkansas found that Salmonella typhimurium can live in the intestines of a beetle for at least 60 days. I say at least because they quit looking after 60 days. It might be longer. So if we have a downtime of 60 days, well, that doesn't necessarily mean that we've gotten rid of all the beetles. We may have cleaned and disinfected, but if the beetles come back in and they can still have Salmonella in their intestines and a chicken eats that beetle, well, then we haven't made a whole lot of headway. Next slide. There are 3 species of rats and mice that live and can be commonly found in chicken houses in the United States. The roof rat, the Norway rat, and the house mouse. Understanding their behavior and their location and knowing which one you have in your poultry house will help you know how to control them. For example, the roof rat. Where do you think they live? Up in the roof. They live in that false ceiling. They live in the insulation. They come down the wires, suspending the feeders and waterers to eat and drink and go back up. Their feet never touch the ground. So if I put rat bait all around the perimeter on the outside of my poultry house, am I going to kill roof rats? No, because they never go there. So we need to know what type of rodent we have infesting our poultry house to know how to properly eliminate them. And it might be Norway rats on one farm, and another farm 5 miles down the road might be roof rats, or it may be the house mouse. Next slide. Kate Hayes, when she was working on her master's, was trying to understand that concept of how important it is to control rodents. And so around their breeder farms, they had bait stations and tin cats, those traps that catch the mice but don't let them get back out. And she counted the numbers, monitored the level of mice, and as you can see, the number went up in the fall, came back down in the winter and spring, back up in the fall the next year, came back down. Now, why do you think the number of mice would come up in the fall? Why is it we'll probably see more mice inside of our poultry houses now than we did 2 months ago? It's because it's getting cool. They're looking for a warm place to eat. And we're harvesting crops. When we harvest crops, we disrupt their habitat, and they go look for a nice, safe place, like a chicken house. Next slide. So Kate cultured the inside of those boxes, and lo and behold, salmonella levels inside of those boxes came up in the fall and went down in the winter. Back up in the fall, down in the winter. Where is salmonella coming from in those bait boxes? From the mice. The mice are bringing salmonella and are a big risk for us on all our farms. Next slide. So cleaning and disinfecting. I didn't write this list as an exhaustive list of this is what you have to do. I wrote it just as an example of things you can do, but I wanted to emphasize, whenever we clean out, let's say a broiler breeder house, we're going to take out the slats, we're going to remove the litter, blow down, maybe wash down. Where do you think the mice went that were down under the slats, living down in the droppings from the hens? They went away. When we take those slats out, they go away. Where do they go? They go next door. They go in the woods. They go into the walls. Then when the house warms back up and everything's set back up again and there's food and water for them, where do they think come? They come right back in again. So we want to bait for rodents the minute the birds leave the house. That way they're accustomed to eating and drinking, and we replace it with bait, and that helps reduce the risk of them running away and then coming back again. We want to have our insecticide as the last thing we do before we bring in litter. Why? Because those beetles are migrating away same way, but we can't bait them in the way we do the rodents. But if we put a barrier of insecticide, so as they come back in, they have to go through that barrier of insecticide, residual insecticide, and it'll kill them. And so that way we kill them before they come in and live and reproduce and infect our flocks. Next slide. Feed. I've been involved in one large outbreak that was associated with feed. The initial introduction was by feed, but it wasn't maintained by the feed. So feed can be a source of salmonella, especially for your breeders. It's important that we understand that and minimize the risk from the types of ingredients we use, to pelleting our breeder feed, to the use of organic acids and formaldehyde products. So I could spend a whole talk just talking about feed. So keep in mind, though, that our feed source can be a source of salmonella. Next slide. Water. Birds drink twice as much water as they eat feed. So if they eat 1.5 pounds of feed, they're going to drink 3 pounds of water, or almost 1/2 gallon of water per bird. And if that water source has salmonella in it, then they're going to drink salmonella. But also, if you look at that nipple drinker, even though water flows out, water can get up inside of those water lines. And if you've ever cut a water line and run your finger inside, you feel that slippery, slimy, that's biofilm. And salmonella makes biofilm and Salmonella can live inside those water lines. And so chlorination and water disinfection is important for us as a Salmonella control program. And it's an easy thing to do. Next slide. Last topic I'll talk about is poultry litter. Like every living organism, Salmonella needs water to survive and reproduce. Now, I did say there are some that can live in dry environments, but they won't reproduce. And if the water activity in the litter gets above 25%, that's enough water for Salmonella to reproduce. So we want to try to keep water activity low. That will keep Salmonella from reproducing. Won't kill it, but it won't reproduce. The other thing about Salmonella, just like its kin E. coli and some of the other pathogenic bacteria, is they like an alkaline environment, high pH litter environment. So we want to do things that we drive the pH of the litter down and use products like propionic acid or aluminum sulfate or sodium bisulfate to keep that pH low so that it's less than a happy place for the Salmonella to survive and reproduce. And with that, I'll be happy to turn over the program to Dr. Burden.
Yeah, thank you, Dr. Hofaker. As always, that was really informative. So we're going to move on, and the next part of this presentation is going to focus a lot on what you can do within the house to help mitigate Salmonella. And so I'm going to go ahead and apologize because this part I get really excited about. So I'm going to try to make sure that I speak slowly so that everybody can hear me and that I speak clearly. But so we'll just jump right in on this slide. There are a few things that I like to do when I go into a chicken house, and that's actually to look around and see if we've got anything that doesn't belong there. So one of my favorite pastimes is to go in at night or to go in with some of the people that work there and kind of see how they handle themselves inside of the house. So on this slide, we actually have a picture of a pine siskin. And some of y'all may know that in 2009, there was a large die-off of the pine siskins in the eastern U.S. And what happened there was a lot of those pine siskins had Salmonella typhimurium. So we do have songbirds. There was American goldfinches that died in 1998 because of Salmonella typhimurium. So there are those wild birds, those songbirds, that can get into the house and wreak havoc. So just a few things that I've seen in the houses, and all of these can carry Salmonella. So I've actually seen pets walking through houses with the owners. I've seen dogs that are used as retrievers almost to find, dead birds in the house. I've seen cats that have been used for rodent control, and that's, while a cat might actually be able to catch some mice, that's kind of frowned upon because it's really hard to swab a cat's rear end to make sure that they aren't carrying Salmonella. So that's always a fun time to try to swab a cat's rear end. The other things that we've seen, I've seen a skunk in a house early morning. That was kind of weird. Armadillos, sparrows, and finches. Next slide, please, ma'am. So a few other things that I've seen snakes, seen multiple robins that are usually nesting on the eaves of the house on the outside and on the fans, the grills and stuff like that where the fans are at. I've seen pigeons. A lot of us know that, or if you didn't know, pigeons can also carry Salmonella and spread it around. A lot of the times it's Salmonella typhimurium, but it could be other Salmonellas as well. And then just like Dr. Hofaker was saying, mice and rats throughout the house, you'll see different kinds. I've seen a lot of them when you clean out a house, they run to the house next door or run to the house across the street so that they can continue to eat and feel safe in the chicken house. So baiting before you actually clean out is a great idea to keep those mice and rats from moving. Next slide. So some of the things that you can actually do when you're talking about a commercial poultry house is you can go in and you can either go in at night or go in during the day and make sure that all the lights are off, that it's not bright in there, and you can see where light is leaking through in the house. So if you've got a curtain-sided house, which, you know, some of our older houses are still like that, some of the houses in the Midwest and out west are still like that, that poses a large opportunity for things to get into the house because you've got a curtain-sided house instead of a solid wall house. What you can do is you can go in and you can see if there's any light that's actually coming through the house, and that's where you need to pay attention to make sure that this wildlife is not getting in. The last thing that you could do is you could look at structural problems for the house itself. Next slide. So what we mean by structural problems is with our older houses or areas where erosion is prevalent, you might see that, you know, some of your foundation is starting to get exposed. Make sure that there's no holes down in the foundation or cracks in the foundation for animals to get in. The farther away vegetation is, the less likely you're going to have a habitat for snakes and rats and mice to hide in. So if you put a little bit of gravel out there or a concrete pad to keep that vegetation away, or if you keep the grass cut really short, you can help deter pests from making their way into the house. You also need to make sure that you know where your biosecure areas start and make that very evident so that you're not actually bringing in your pets or you're not actually bringing in pests that don't need to be in there. One of the things that you need to pay attention to on the outside of the house, and this goes for the backyard participants as well, you need to make sure that there's no wild birds that are hanging out in the eaves of your house. So you need to look, if you see any robin nests, if you see any sparrows, you know, pigeons, make sure that you're doing something to keep those wild birds off the sides of your house. Next slide. So some of the things that you can do to actually prevent salmonella from infecting your poultry is it has a lot to do with your equipment, your shoes, and your clothing. So if you've got residual bacteria from a previous flock, the salmonella can often be found in that fecal material and that dust material that's still in that house. So you need to try to clean the surfaces before the disinfectants are applied. This actually helps to improve the efficiency or the effectiveness of the disinfectant. So going back to what Dr. Hofaker told us, we do need to make sure that we do a little bit of something, some sort of cleaning before we apply the disinfectant. The other thing that you need to be aware of is your equipment and your clothing and how are you using it. So if you're using the same equipment or clothing between multiple houses, you could actually increase the potential for introduction from one house to the next. Next slide. Another thing to think about is actually how you're going to handle dead birds in the house. So your mortality and your morbidity, the dead birds, y'all should remove them in a timely manner and dispose of them appropriately. Carcasses can serve as a reservoir for salmonella and can infect your other birds in the house. Personnel should try to work from the healthiest birds or the youngest birds to the sicker or older birds to reduce the potential for spread. And you should also know the status of your spike males, your replacement hens, or your replacement pullets. And then if you're working exclusively in turkey operations, you need to know if the semen that you're using for artificial insemination is contaminated prior to bringing it into the house. Next slide. So one of the biggest things that you can do is you can actually rely a lot on training. So are you training the people that work on your farm? They should all be trained and they should adhere to standard operating procedures. Usually these standard operating procedures are created by identifying the potential risky situations, such as, does this person have birds at home? Make sure that they don't have those dangerous contacts or that they don't have those high-risk contacts. Sometimes we will see that people will have pet birds at home and they don't tell their employer, and then they will actually bring something into the chicken house. So that's super risky. The 14 biosecurity principles can actually help producers identify these potential areas of risk. Next slide, please. So basically, when we're talking about Salmonella and we're talking about biosecurity, biosecurity is a supplementary measure to keep diseases out of the house, but it's also a method to keep other houses from getting a disease. Mainly for Salmonella, we're talking about birds that might already have it. So your biosecurity will actually help reduce introduction of new Salmonella serotypes and will keep your neighbors from getting your Salmonella. Next slide, please. So now I'm actually going to turn it back over to my colleague, Dr. Gaines, and he'll talk a little bit about the biosecurity resources that are available from USDA APHIS.
Thank you, Dr. Burden and Dr. Hofaker. I'll conclude our presentation with an overview of the resources available through USDA APHIS that will help you implement some of the biosecurity practices that we've discussed here today. APHIS Veterinary Services has developed a library of checklists that provide practical tips and recommendations. We encourage you to visit the Defend the Flock website to view and download these materials. All the checklists are available in multiple languages, including Spanish, Chinese, Vietnamese, and Tagalog. On our website, you'll find lots of other free tools, including recordings of prior webinars, newsletters, videos, and other resources. We're also excited to announce that the Defend the Flock calendar is back for 2021. To order, please visit bit.ly/APHIS_publications and search for PA-2261. You can also go to our homepage and submit a photo for a future calendar. APHIS has also created social media content to help promote biosecurity. Infographics covering many of the best practices that we've covered here today are available in English and Spanish. We hope that you will share these with your colleagues and fellow poultry keepers on Facebook, Twitter, Instagram, and other social media channels to make sure everyone is using biosecurity every day, every time, no matter the size of the flock. Be sure to check out more helpful information on our social media channels. This presentation, along with answers to your questions, will be available for download from the Defend the Flock website shortly. Be sure to follow Defend the Flock on Facebook and Twitter to be notified when the presentation is available. And use the hashtag FlockDefender when sharing or posting information to help spread the word that biosecurity is the best way to keep flocks safe from Salmonella and other infectious diseases. And before we go, on behalf of APHIS, thank you, Dr. Burden and Dr. Hofaker, for sharing your valuable insights and knowledge with us today. And thank all of you for joining us on this webinar. And let's keep our poultry healthy together.